Now that all of Nvidia's 50 series video cards are out, I wanted to see how they performed in Fortnite. So we often run benchmarks for video games that lots of people don't play that much. No shade against Shadow of the Tomb Raider, but it has a built-in benchmark, which is really convenient for us when we're running tests. But it doesn't represent the kind of games that people actually play, which is why I wanted to find out how games like Fortnite, a game that millions of people play every single day, actually performs with the newest video cards from Nvidia. So I sat down and I figured out a benchmark for Fortnite. Let's show you how it works. So one of the nice things about Fortnite is it has the ability to record your game sessions, but the recordings don't last forever. Every time there's a major patch for the game, your recordings stop working with the new version of the game. But as long as I did my testing within a short period of time, I was able to get repeatable, reliable results from inside the game. This is a recording of me playing a couple days ago. And if you look in the top left corner, I'm using this overlay with an Nvidia tool called FrameView, which ties into the PresentMon interface built into Windows and actually tells you how many milliseconds each frame takes to render. The milliseconds between frames, as we'll see in a second, can convert to frames per second. For the next part, I'm going to need an assistant and a dry erase board. Okay, each frame in Fortnite, when it's running at 350, 400 frames a second, is around 2.86 milliseconds. Now, first we need to convert milliseconds to seconds. So we multiply 1,000 milliseconds on the bottom and 1 second on the top. So these units are going to cancel out. We learned this in high school chemistry, everybody. And we get 0.00286 seconds is how long each frame takes to render. Now, the time each frame takes to render inverted is actually the frames per second, because right now it's this per frame. So if we flip this over and do 1 divided by 0.00286 seconds, we get frames per second, and that is about 387 FPS thereabouts. So that's how you can go away now. We're good, thank you. Now we know how long each frame takes to render. It lets us have a relationship with the frames per second, and we're going to use a tool called CapFrameX to plot that all out on a lovely graph. So on CapFrameX, what we're seeing here is these are the actual frame times for each frame that's in this demo. The demo is about 260 seconds long. The way I recorded is I set FrameView to record 260 seconds worth of gameplay and triggered it at the exact same time every single time I launched the replay of the demo in Fortnite. And so you see variance. This is a 4090 at 1440p. We're going to go up here and let's look at a 5070 at 1440p. And this one's really interesting because there's some huge spikes here at about the 35 second mark of this demo. And those are when we had bad micro stutter, or there was some sort of shader compiling, or something weird happened on the computer. And while from run to run, these spikes were in slightly different places, they were fairly consistent. There were almost always a couple of fairly chunky spikes. Now, the interesting thing is because frame rate and frame time are inversely related with each other, we can invert that, and this is the average frames per second for the same card. So we can see around that 35 second mark right here, again, there's a huge dip in frame rate, but it's only going down to 120 frames a second. So you'll feel that, but it's not going to feel too bad. And the interesting thing about this card is with the competitive settings that I've set up for this game, we're actually still getting more than this monitor can display pretty much all the time, except for in this initial window when it sags way down. So this is actually the results we got at 1440p. We ran the numbers at 1440p and 4K, and as you can see, the 4K number, the 1440p number rather, there's not that big a gap between the 5080, 4090, and the 5090. So the orange bar here is the 1% lows, and what that means is it's the frame times that are the slowest 1% of frame times. So the longest time it took to generate the frames is then converted into frame rate by doing the inversion thing that we did on the whiteboard a minute ago. So here we see the 4K numbers. The interesting thing here is that the 5090 really runs out ahead at 4K. Jumping from the 5080 to the 5090, it's a 42% leap almost. And from the 4090 to the 5090 is a 30-ish% leap. It's pretty impressive. The 1% lows, there's also a commensurate leap. When we see here, the 4090 to the 5090, 1% low is a 40% increase as well. So this is where we see the benefit of fast GPU, fast CPU, really wide memory bus versus the other parts. Still, 5070 at the competitive settings, 165 frames a second average. The lows are a little measly at 104. I would like to see higher lows than that on a game like this. So I mentioned that I use the competitive settings. When I say the competitive settings, I mean the Fortnite subreddit's recommended settings from 2024 to minimize microstutter in Fortnite, which is an ongoing problem. And we can get in here and actually see what the settings are if you're curious. So on a modern GPU, you want to use the DX12 mode. There is a performance renderer that is, people recommend it. It seems like you lose a lot of the optimization benefits of your more modern video card. The big stuff to turn off is to disable DLSS and switch to TSR. That's the temporal super resolution. It lets you render at a lower resolution upscale. It seems to be a little bit less stuttery in Fortnite than DLSS is. The other thing is to turn off Nanite. Nanite is very fancy and makes your games look good and lets you do global illumination, but it has a performance cost. And if you know, as they used to say, frames win games. So it goes. Shadows to medium, you want them for depth perception, but you don't need them on all the way and they don't need to be fancy. Global illumination off, it's another big performance hit. Reflections off. View distance high, because you want to be able to see people and shoot them from far away when they can't see you. And I do textures on high and effects on medium. And post-processing isn't going to impact performance too much. I don't like motion blur, so I turn that and depth of field off, and that's a medium setting. So that's it. That's the settings I use for testing. This machine is a Ryzen 9800X 3D, so it's pretty much the fastest gaming CPU you can get right now. And you can try it at home. You can get FrameView, you can record a demo, you can play the demo back, and then you can see the results in CapFrameX if you want to give it a try. Let us know how your results are, and we'll see you next time. Bye.